Hello students and good morning to you all. So today I am doing class per class 12 science. So in the last online class also we were doing the matrix. So today we'll do matrix exercise 1 that is page number 135 from SND book Higher Mathematics for class 12 by SND, and this section, each question carries 5 marks. This is the section where each question carries 5 marks. So let's start the problem now. So now we will do question number 5. So question number 5 is, if capital A plus I3 is equal to, third order matrix is given. In the first row 1, 3 and 4 are given. In the second row -1, 1 and 3, and in the third row -2, -3, 1 is given. Okay, so evaluate A plus I3 into A minus I3, where I3 represents 3 cross 3 unit matrix. So let's do question number 5. So I'll show you on the blackboard, right? We'll do this question now. So you have to evaluate A plus I3 into A minus I3. So this matrix A plus I3 is given. Okay, so you have to get A plus I3 into A minus I3, where I3 represents 3 cross 3 identity matrix. What do you mean by I3 identity matrix? I3 is equal to, in the first row 1, 0, 0, in the second row 0, 1, 0, in the third row 0, 0, 1. That is, I3 can be written as, this is the leading diagonal 1, 1, 1. All the elements will be 1 and all other elements will be 0. This is the identity matrix of order 3. So this is the leading diagonal, all the elements will be 1 and all other elements will be 0, right? This is known as identity matrix of order 3. Okay, now A plus I3 is given. You have to find out A plus I3 into A minus I3. Already we know A plus I3, but we don't know A minus I3. You have to find it. Okay, so here given is, so what is given out here? A plus I3 is equal to, this is 1, 3, 4, -1, 1, 3. This is -2, -3, 1. So we have copied the given one, right? So now let us put the value for I3. What is I3 here? Or A plus, what is I3 out here? It is 1, 0, 0, 0, 1, 0. This is 0, 0, 1, right? Is equal to, next it is 1, 3, 4, -1, 1, 3, -2, -3, and this is 1. Is that clear now? So now what we will do here is, let us take this identity matrix to the right side. This is just like you're solving X, okay? But here you have to solve for A, or A is equal to, what is it? 1, 3, 4, -1, 1, 3, and then -2, -3, 1. Is that right? Next, this identity matrix, take to the right side, so it becomes minus. So minus, this is 1, 0, 0, 0, 1, 0, and this is your 0, 0, 1. Right? Is that clear now? So now let us find out the matrix A, or A is equal to, now here, first row 1, 3, 4, second row -1, 1, 3, third row -2, -3, 1. So let us make it plus. Now you know that that is actually -1. So -1 is the scalar multiplication of this matrix, isn't it? So multiply all the elements here by -1. Okay, so it becomes plus. So multiply by minus here, -1, 0, 0, 0, -1, 0, 0, 0. This is your -1. Okay, so this is the addition of two matrices, right? So this is the addition of two matrices. So what is A now? So A is equal to, now 1 minus 1, that is 0, isn't it? 1 minus 1 is 0, 3 plus 0, 3, 4 plus 0 is 4. Next, minus 1 plus 0, this is minus 1, 1. 1 minus 1 is 0, then 3 plus 0 is 3, right? Minus 1 plus 0, minus 1, 1 minus 1, 0, 3 plus 0 is 3, and the last one is minus 2 plus 0 is minus 2, minus 3 plus 0, minus 3, and then 1 minus 1 is always 0. So this is the matrix, A matrix, okay? So now, what is to be determined now? You have to find out A minus I3 now. Now let us find out A minus I3. So which is equal to, just now we got the matrix A. What is matrix A? It is 0, 3, 4, then minus 1, 0, 3, then minus 2, minus 3, 0. Then write down minus. Okay? Minus, what is I3 now? What is I3 here? This is the third order identity matrix. 1, 0, 0, 0, 1, 0, then 0, 0, 1. Is that clear now? Now next you have to simplify it. So this is minus 1. Minus 1 is the scalar multiplication of this identity matrix. You have to multiply all the elements of the identity matrix by minus 1. So which is equal to, now first matrix remains same, 0, 3, 4, minus 1, 0, 3, and what is the third row now? Minus 2, minus 3, 0. Minus 2, minus 3, 0. Make it plus now. Make it plus. So this is minus 1 is the scalar multiplication of this matrix. Multiply all the elements of the identity matrix by minus 1. So what do we get? Minus 1, 0, 0, 0, minus 1, 0, 0, 0. This is your minus 1. Okay. So now again, this is the addition of two matrices. So you can add those corresponding elements. 0 minus 1, minus 1, 3 plus 0, 3, 4 plus 0, 4, minus 1 plus 0, minus 1, 0 minus 1, minus 1, 3 plus 0, 3, minus 2 plus 0, minus 2, minus 3 plus 0, minus 3, and 0 minus 1. This is your minus 1. So I think you have understood it. So just now we have determined the matrix A minus I3. So this is the value for A minus I3. Okay. Now let us find out A plus I3 into A minus I3. That is the multiplication of two matrices. Okay. So you know how to multiply the two matrices now. So therefore this is your A plus I3 into A minus I3. Okay. So what was A plus I3? This is given, right? So is equal to, what is given out here? 1, 3, 4, next, minus 1, 1, 3, minus 2, minus 3, 1. This is your A plus I3. Now what is A minus I3? Here A minus I3, just now we got this A minus I3. Let us write it, minus 1, 3, 4, minus 1, 3, then minus 2, minus 3, and minus 1. Right? So this is the matrix now. Now you have to multiply these two matrices. Let us multiply them. How can you multiply these two matrices? Row by column. First row should be multiplied by first column, but the corresponding elements should be multiplied, right? 1 into minus 1, minus 1, 3 into minus 1, minus 3, 4 into minus 2. This is minus 8. Is that clear? This is the first element of the first row. Next, first row by second column. 1, 3 is 3, 3 into minus 1, minus 3, 4 into minus 3, minus 12. Right? Next, let us take it once again. 1, 3 is 3, 3 into minus 1, minus 3, 4 into minus 3, minus 12. Right? 1 into minus 1, minus 1, 3 into minus 1, minus 3, 4 into minus 2, minus 8. Again, first row by third column. 4 1s are 4, plus 3 3s are 9, minus 4. Right? 4 1s are 4, 3 3s are 9, 4 into minus 1 is minus 4. Right? Now second row. Now multiply second row by first column. Minus 1 into minus 1 plus 1, 1 into minus 1, plus 3 into minus 2, minus 6, right? Again, second row by second column, minus 1 into 3, minus 3, 1 into minus 1, minus 1, 3 into minus 3, this is minus 9, right? Minus 1 into 3, minus 3, 1 into minus 1, minus 1, 3 into minus 3, minus 9. Again, second row should be multiplied by the third column, corresponding elements should be multiplied. Minus 1 into 4, minus 4, 1 into 3, plus 3, 3 into minus 1, minus 3. Is that clear? Next, this third row should be multiplied by first column. So what do we get? Minus 2 minus 1 multiplied by the 2, minus 3 into minus 1 plus 3, 1 into minus 2, that is minus 2. Let us check it once again. Minus into minus plus 2, minus into minus plus 3, plus into minus minus 2, right? Next, this third row should be multiplied by second column. Minus 2 into 3, minus 6, minus 3 into plus, minus 3 into minus 1 is plus 3, and 1 into minus 3 is minus 3. Let us check it once again. Minus 2 into 3, minus 6, minus 3 into minus 1, plus 3, 1 into minus 3, that is minus 3. Again, this third row should be multiplied by third column. Corresponding elements should be multiplied. Minus 2 into 4, minus 8, minus 3 into 3, minus 9, 1 into minus 1, that is your minus 1. So we have multiplied these two matrices, okay? So let us find out, let us simplify it once again, okay? So let us simplify it once again. So now we have to simplify minus 1, minus 3, minus 8, right? So which is equal to, what is it here? What is minus 1, minus 3, minus 8? All are same sign, add them. Minus 12, this is minus 12, 3 gets cancels, minus 12, 4 cancels, 9, okay? This also 1 gets cancels, this is minus 6, minus 13, this one minus 4 only, right? This one 3 only, this one minus 6 only, this one minus 18. This is your minus 18. But this is the value of the matrix A plus I3 into A minus I3. That is, we got the answer. That is, what is the matrix A plus I3 into A minus I3? That is, in the first row minus 12 and 9. Second row minus 6, minus 13 and minus 4. And in the third row 3, minus 6 and minus 18. Is that clear? So now we'll do the next problem. Now next question, let's do question number 6.1. Let f of x, you know f of x is the function of x. So f of x given here is 2x square plus 3x plus 5, and capital A is equal to second order matrix is given. In the first row 2, 1, and in the second row it is 3, 4. So you have to find out f of A, that is function of the matrix A. Okay, that is you have to find out f of A. So let's do it on the blackboard. Now this is the function of x is equal to 2x square plus 3x plus 5. That is, any expression in terms of x is known as the function of x. So this is known as polynomial also. Polynomial of degree 2. Here the hash power of x is 2. This is known as polynomial. Polynomial in x of degree 2. Okay. And what is a here? It is the second order matrix 2, 1, 3, 4. Find f of a. Now let us write down the given function. That is, given function here is f of x is equal to 2x square plus 3x plus 5. Right? Let us put x is equal to a, because you have to get the value for function of the matrix A. Or let us put capital A instead of x is equal to, this is your 2a squared plus 3a plus, you have to write 5 in terms of matrix also. How can you write it? So you should know this property of identity matrix. A dot I is equal to I dot A is equal to A. It is just like multiplying this matrix A by 1. Ideal matrix means you think it as 1, but you can't write 1 out there. Okay? So A dot I is equal to I dot A is equal to A. But this 5 is a scalar quantity, right? So you have to convert into matrix. So you have to write plus 5i. You have to write 5 into I. So if this is a scalar multiplication, 5 into I is equal to I into 5 is equal to, you can write here which is equal to 5. Okay? So this 5 should be converted into matrix form. So you should write here 5 dot I. Okay? Now f of A is equal to 2 into what is A square? This is A dot A plus 3A plus 5I. Now let us write down the matrix A and matrix I on the right hand side. What do you mean by this I? This I is the identity matrix of order 2. What do you mean by identity matrix of order 2? It should be 1 0 0 1. In the first row 1 0, in the second row 0 1. Okay? So 2 into what is A out here? What is A? It is the matrix 2 1 3 4. Again, what is A? It is also 2 1 3 4. Is that clear now? Plus 3 into what is A again? This is the same matrix 2 1 3 4, right? And plus 5. Plus 5, what is I? 1 0 0 1. Here the ideal matrix is 1 0 0 1. So let us simplify it. So now you can multiply these two matrices. You know how to multiply the two given matrices. You can do row by column, right? First row by first column. 2 2s are 4 plus 1 3s are 3. Next, first row by second column. 2 1s are 2 plus 1 4s are 4. So this is the first row of the matrix. Okay. Next, second row by first column. 3 2s are 6 plus 3 4s are 12. Right? Next, 3 1s are 3 plus 4 4s are 16. Is that clear? Next, plus. Now we have to multiply this. This just like 3 is the scalar multiplication of this matrix. That means you have to multiply all these elements by 3. So what do we get? 3 2s are 6, 3 1s are 3, right? 3 3s are 9, 3 4s are 12. Is that clear now? Next, plus. Here 5 is also the scalar multiplication of that identity matrix. So multiply here, 5 1s are 5, 5 0s is 0. This is also 5 0s are 0, 5 1s are 5. Is that clear now? So now let us simplify it further. We can simplify it further, right? So let us write it here. So is equal to 2. Now this is the second order matrix again. 4 plus 3, 7. 2 plus 4, 6. 6 plus 12, 18. 3 plus 16 is 19. Right? Plus, you can add these two matrices. You can add those two matrices. They have the same order, isn't it? Now corresponding elements should be added. That means 6 plus 5, 11. 3 plus 0, 3. And 9 plus 0, 9, and 12 plus 5 is 17. So I think I've understood it. So again, you can simplify it further now, which is equal to, now again 2 is the scalar multiplication of this matrix. You can multiply all these elements by these 2. 2 7s are what? 14, 2 6s are 12, 2 18s are 36, 2 19s are 38. Right? Plus, now this is 11, 3, 9, and this is your 17. Okay? Now next, which is equal to, now add these two matrices, corresponding elements can be added. 14 plus 11, that is 25, 12 plus 3, that is 15, 36 plus 9. 45, 38 plus 17, that means it is your 55. So this is the final answer. So I think you have understood it. So I'm going to the next question now. So now we are doing question number 6, number 2. If matrix A is equal to, again second order matrix is given, in the first row 1 2 and in the second row 2 1, and function of x, that is f of x, is equal to x square minus 2x minus 3, so that f of A is equal to null matrix. You have to prove that f of A is equal to null matrix. So here matrix A is given, that is in the first row 1 2 and 2 1, and function of x is given, that is f of x is equal to x square minus 2x minus 3. You have to show that f of A is equal to null matrix. Okay, now I'll show you on the blackboard. Now 6 number 2. If A is equal to first row 1 2 2 1 and f of x is equal to x square minus 2x minus 3, you know that this is the function of x. Any expression in terms of x is known as the function of x, or x square minus 2x minus 3 is known as the polynomial of degree 2, because here the highest power of x is 2. Okay, so that f of A is equal to null matrix. F of A is equal to O, that is O is known as the zero matrix or the null matrix. You have to prove, since this A is second order matrix, you have to find out O as a second order zero matrix, that is 0 0 0 0. You have to prove it. Okay, so here again what is given here now? Here given is f of x is equal to x square minus 2x minus 3. It is just like your previous problem, that is 6 number 1. Okay, let us put a capital A matrix for x. So f of A, because you have to get f of the matrix A is equal to a square minus 2a minus this, now this becomes 3i. Only 3 is there. You have to multiply it by the identity matrix I. Okay, so I told you about this I, isn't it? This is the identity matrix. Since f of A is in terms of the matrix, you have to convert this constant 3 in terms of matrix. What is the method for converting it into in terms of matrix? You have to multiply it by the identity matrix I, minus 3 into I. This minus 3 is a scalar quantity. Okay, or f of A is equal to, this is your A dot A minus 2a minus 3i, right? So, or f of A is equal to, what is A in this case? It is 1 2 2 1, right? Again it is 1 2 2 1, right? Minus 2, what is A? 1 2 2 1, right? Minus 3, what is I? This is the identity matrix of order 2. You have to write I as an identity matrix of order 2, since the given matrix A is of order 2 cross 2. Okay, so what is the identity matrix of order 2? It is 1 0 0 1. It is 1 0 0 1, right? So let us simplify it. Or f of A is equal, let us multiply these two matrices. Now you can multiply them easily. First row by first column, 1 1s are 1 plus 2 2s are 4, right? Again 1 2s are 2 plus 2 1s are 2. Next, this second row by first column, 2 1s are 2 plus 1 2s are 2, right? Next, 2 2s are 4 plus 1. So this is the matrix multiplication. Now plus, now multiply by minus 2 out here. Multiply all these elements by minus 2, because minus 2 is the scalar multiplication of that matrix A in this case, right? So minus 2, minus 4, minus 4, minus 2, plus. Now multiply by minus 3 there. Minus 3 into 1, minus 3, minus 3 into 0, 0, minus 3 into 0, 0, minus 3 into 1, that is your minus 3. Is that clear? Now next, so let us simplify it further now. Or f of a is equal to, how much is it now? 4 plus 1, 5, 2 plus 2, 4, 2 plus 2, 4 again, 4 plus 1 is 5. Next, plus, you can add those two matrices here, second and third matrix. They are of same order, so you can add them. Minus 2, minus 3, minus 5, right? Minus 4 plus 0, minus 4 plus 0, that is also minus 4, and minus 2, minus 3, that is your minus 5. So again, you can add these two matrices, they are of same order, or f of a is equal to 5 minus 5, 0, 4 minus 4, 0, 4 minus 4, 0, 5 minus 5 is 0, right? Or what is f of a is equal to, this is the null matrix O, so it is proved. Is that understood now? So we'll do the next question now. So now we will do question number 7. If capital A is equal to third order matrix is given there. In the first row, the elements are 1, x and minus 2. In the second row, 2, 2 and 4. And in the third row, 0, 0 and 2. And also it is given that a square plus 2i3 is equal to 3a. So you have to find out the value of x. So here I3 is the unit matrix of order 3. You know unit matrix of order 3. I3 is equal to, in the first row there are 3 elements, 1, 0, 0. In the second row, 0, 1, 0. And in the third row it is 0, 0, 1. So using this identity matrix I3 and the matrix A, you have to get the value for x, and also the condition is given out there. The condition is a square plus 2i3 is equal to 3a. So using the condition given, that is a square plus 2i3 is equal to 3a, you have to find out the value for x. So I think you have understood the question. Now let's do the problem on the blackboard. Number 7, if a is equal to 1x minus 2, 2, 2, 4, 0, 0, 2, and a square plus 2i3 is equal to 3a, find x. Here I3 is the identity matrix of order 3. Okay. So what is I3 here? This is the identity matrix of order 3. So how do you write I3? This is the third order matrix, identity matrix. All the leading diagonal will be 1, 1, 1, and all other elements will be 0. Okay. So let us write down this given, second given part. So here given here is, it is a square plus 2i3 is equal to 3a. This equation is given. This is known as matrix equation, because this equation is given in terms of the matrix A and identity matrix I3. So this equation is known as matrix equation. Okay. What is a square? A dot a plus 2i3 is equal to 3a. Now let us put the value of the matrix A. What is matrix A now? 1x minus 2, 2, 2, 4, and then this is 0, 0, 2. This is A matrix. Again, 1x minus 2, 2, 2, 4, third row, 0, 0, 2. Same matrix A dot A plus 2. What is I3 here? This is the identity matrix of order 3. So it is 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the identity matrix. So I will write down the identity matrix. All the elements in the leading diagonal will be 1, 1, 1, and all of the elements will be 0. Okay? Is equal to 3. 3 into, what is A now? What is A? It is 1x minus 2, 1x minus 2, second row, 2, 2, 4. Second row is 2, 2, 4. It is 2, 2, 4. Third row is 0, 0, 2. Third row is 0, 0, 2. Right? So now, let us multiply these two matrices, right? Or now let us multiply them. First row by first column, 1 1s are 1 plus x into 2, 2x minus 2 into 0, minus 0. This is the first element of the first row. Again, first row should be multiplied by the second column, 1 into x, x plus 2 into x, 2x minus 2 zeros are minus 0. Okay. Again, first row by third column, 1 into minus 2, minus 2, x into 4x minus 2 into 2, minus 2 into 2 is, this is minus 2 into 2 is minus 4, right? So this is the first row, right? So next one, second row by first column, 2 1s are 2 plus 2 2s are 4 plus 0, right? Next, second row by second column, 2 into x, 2x plus 2 2s are 4, this is plus 0. Next, second row by third column, 2 into minus 2, minus 4, 2 4s are plus 8, 4 2s are plus 8, right? So is that clear? So this is the second row. Next, now this third row by first column, 0 1s are 0 plus 0 2s are 0 plus 2 zeros are 0. Okay. Next, second row by second column, 0 into x, 0 plus 0 into 2, 0 plus 2 into 0, 0. Is that clear now? This second row is multiplied by second column. This third row is multiplied by second column. 0 into x, 0, 0 2s are 0, 2 zeros are 0. Next, this third row should be multiplied by the third column. 0 into minus 2, 0, plus 0 into 4, 0, plus 2 2s are, this is 4. So this is your third order matrix. So we have multiplied these two matrices, okay? Plus, now here, 2 is the scalar multiplication of this identity matrix. You have to multiply all the elements of the identity matrix by that scalar quantity 2. So it is 2 0 0 0 2 0 0 0 2. Is that clear? And now on the right hand side also, 3 is the scalar multiplication of that matrix. Multiply all the elements by 3 here also. This is 3, 3x minus 6, right? 3 2s are 6, 3 2s are 6, 3 4s are 12. Is that correct? 3 2s are 6, 3 2s are 6, 3 4s are 12. 3 1s are 3, 3x, 6, minus 6. Okay, last one, 3 zeros are 0, 3 zeros are 0, and 3 2s are 6. So this is your right hand side. Okay. So now, let us write down this matrix. Or, so what is it? 2x plus 1. This one 3x. That one 4x minus 6, isn't it? 4x minus 6, right? This is 2x plus 1. This is 3x. 4x minus 6. And this one is 4 plus 2, 6. This is 2x plus 4. This is your 2x plus 4. Then that is 8 plus 8, 16. 16 minus 4 is 12. And this one is 0, 0. And that one is 4. Right? Plus, next one, there is 2, 0, 0, 0, 2, 0, 0, 0, 2. Is that clear now? So next one is, write down the right hand side matrix. That is your, what is the first row? First row is 3, 3x minus 6. Second row 6, 6, 12. Then 0, 0, 6. Then 0, 0, 6. Right? So now you can add these two matrices because they are of same order. You can add them. This is 2x plus 1 plus 2. 2x plus 1 plus 2 is 2x plus 3, then this is 3x, 4x minus 6, right? Next 6 plus 0, 6, 2x plus 4 plus 2, this is 2x plus 6, right? 12 plus 0 is 12, next 0 plus 0, 0, 0 plus 0, 0, 4 plus 2 is 6, which is equal to, now on the right hand side it is 3x minus 6, okay? Then 6, 6, 12, 0, 0, 6. Now we have to get the value for x. So how can we get the value for x? Now these are the equality of two matrices. These are the equality of two matrices. The two matrices are said to be equal if they have the same order and the corresponding elements are also equal. Okay. So now 3x equal 6 equal 2 equal 0 0 6. This is also 0 0 6. So you can equate any corresponding values. You can equate any corresponding elements. Now let us equate 2x plus 3 with 3. 2x plus 3 with 3. You can equate this first element is equal to first element, that is 2x plus 3 is equal to 3, or 2x is equal to 3 gets cancelled 0, or x is equal to 0 by 2, that is always 0. So this is the value for x, which is equal to 0. We got the answer. You may equate 3x is equal to 3x. Here x cannot be cancelled because x may be equal to 0. So without cancelling, or 3x is equal to 3x. So without cancelling, 3x is taken to the left hand side. It is 3x minus 3x. So x within bracket, you can cancel this 3. You can cancel this 3, isn't it? So in this case also x is equal to 0 because x cannot be cancelled because x may be equal to 0. Okay, like 3x is equal to 3x. If you write 3x is equal to 3x, only 3 will be cancelled. Only 3 will be cancelled, right? Or x is equal to x. That means this is valid when x is equal to 0. So x is equal to x is valid when x is equal to 0 only. X is equal to x will be valid when x is equal to 0. Is that clear now? Because you cannot cancel it because x may be equal to 0. So this x is equal to x is valid when x is equal to 0. That means 0 is equal to 0. Is that clear? So we can equate this one also, this one only. That is 2x plus 3 is equal to 3. That means 3 gets cancelled. 2x is equal to 0. So x is equal to 0. Okay. You may equate 4x minus 6 is equal to minus 6. That is also x is equal to 0. 2x plus 6 is equal to 6. That is also, and that is also you will get x is equal to 0. Is that clear now? So the answer is x is equal to 0. You can copy it. So we'll do the next question now. So in the next class also we will do the same topic, that is matrix, exercise 1, page number 135. So this section is from each question carries 5 marks. Okay, so in the next class also we'll do the same exercise. Thank you.